Well, thanks for tuning back in. If you've watched the first video, you got a complete rundown and a good variety of different functions, and you could see the patterns. Hopefully you're able to tap into that. So if you've got that down, you're trying numbers 2, 3, and 4 here, and when I'm graphing these functions, I first want to remember that y equals 1 over x. Well, that just looks like this, so I want to make sure I remember that. 2 over x looks exactly the same. It's just that this part right here, the part that's closest to the origin, with a 2 would move a little farther away. As the number gets bigger, it just moves farther away, but I don't really need us to focus on that too much. I really want to mainly focus on the asymptotes, the domain, and the range. So that being said, let's go ahead and get started. That number 1 right there represents a shift of the original graph to the right 1 unit. And that 1 is an important number because x equals that number is our vertical asymptote. So we have a vertical asymptote of x equals 1. We don't have a horizontal shift here. We don't have a plus or a minus something on the outside. So therefore, our horizontal asymptote will be the same as it was in the original function, the original y equals 1 over x function. Y equals 0 is our horizontal asymptote. So because I have a marker, I can go ahead and draw that just to illustrate that it is a horizontal asymptote. You don't have to draw that. If it's an axis, you can leave it alone. You don't actually have to draw that asymptote. But now, the only other thing we need to really worry about is, well, what's the value for a? The value for a is 2. 2 is greater than 0. So therefore, since 2 is greater than 0, the graph will look like that. That's a hyperbola. And again, how close these points are, these might not be in the exact right spot, but I'm mainly concerned, can you get the asymptotes in the right place? Do you understand the domain and range? And then can you draw the graph actually in the correct quadrants? We can see we have 1, 2, 3, 4 quadrants that the asymptotes divide the plane into, and we have the top right and the lower left quadrants when the a is positive. So I should probably also make mention of the fact that the transformation of the original parent function of y equals 1 over x would look like this. You can always find the a because it's always the numerator of the fraction. You can always find the h, it's what's being subtracted from the x, and you can always find the k because that's the number that gets added to the outside of the fraction. So y equals k is our horizontal asymptote always. X equals h is the vertical asymptote always. And our domain and range then would be the only other things that we need to worry about here. The domain would be all real numbers x, such that x does not equal the vertical asymptote. So we always can find the domain. We can also find the range by looking at the y value. Whatever y value doesn't belong there or doesn't get used in the graph, y such that y does not equal, well, the y value can never be 0 here because the numerator of the fraction can never be 0. And so therefore we say the range of the function is all real numbers y such that y does not equal 0. I think I'll start a new video for each one of the problems. Anyway, by the way, that's it. You've got asymptotes, you've got domain and range, and you've got the graph.